All right, so we're on to example number 7 here. And this is the fifth part of our 5.1. Again, I'm going to stress this. This is probably the most intense lesson because it's all new, and once you get used to the different processes, it gets easier as you go. I promise you that. Okay, anyway, if you look at example 7, we're supposed to factor cosecant squared x minus cotangent x minus 3. Now notice that this is, if we do our u substitution, we have a cosecant and then we have a cotangent. It's not going to work. So what we want to do is think of an identity that you could use, and there's lots of different routes you could probably go, but one of the things I'm looking at is I have a cosecant squared x, and I know from my Pythagorean identities that this is an identity. So I can replace this cosecant squared x with cotangent squared x, and now I'm going to have everything in terms of cotangent instead of mixing the different trig functions. So I'm going to replace this cosecant squared x with 1 plus cotangent squared x, and continuing on, it's minus cotangent x minus 3. I'm going to simplify that. So I get cotangent, and write it in descending order, cotangent squared x minus cotangent of x minus 2. Negative 3 plus 1 is negative 2. And if I do that u substitution again and let u equal cotangent of x, then this becomes u squared, and this is just to make it look easier to factor, and then you go ahead and factor it. This would be u, and it would be minus 2 and plus 1. You don't have to do the u substitution. If you see the answer or the result without doing that, that's perfectly fine. But then in the final answer here, we're going to replace the cotangent. We're going to throw that in place of the u, and you get cotangent of x minus 2 times cotangent of x plus 1. And you're going to see application of this down the road, but for right now, we really just need to get used to these identities and how to use them. And our class Zoom time is going to be to go over questions for the most part and do some clarification. Again, bear with me here because this can be challenging, especially at first. Looking at example 8. Okay, I have a sine of t plus cotangent of t. We need to put these in parentheses just to make it a little more clear. So sine of t plus cotangent of t times cosine of t. There isn't a Pythagorean identity to use. We don't have anything that we can factor out. A third option, recall, is to rewrite in terms of sine and cosine. So that's what I'm going to go ahead and try to do. I have sine of t, it's already in terms of sine and cosine. Cotangent, recall, is cosine of t over sine of t. And then that's multiplied by this cosine of t. Okay, I can put that over 1 since I have fraction and another fraction multiplied together. So sine of t, I'm going to put that over 1, plus cosine of t times cosine of t is cosine squared t. You don't have to have these parentheses here, but it can be helpful maybe to just for organization. Sine of t, now what do I have? I have a fraction, so I'm going to find a common denominator, which is sine of t. So I'm going to multiply over here by sine of t on the top and on the bottom. When I multiply sine of t times sine of t, I get sine squared t. So then that becomes sine squared t plus cosine squared t over sine of t. Look at the top. Think about your identities. Can you replace sine squared t plus cosine squared t with an identity? And the answer is yes, it is exactly equal to 1. That's the first Pythagorean identity that we looked at. So we end up with 1 over sine of t, and that is the same thing as cosecant of t, and that is the simplified version for example 8. Okay, and last but not least, this is another method. This is the last one for 5.1. we have a fraction, and I'm not adding it to another fraction or subtracting another fraction. What I want you to do in this problem is rewrite the fraction, rewrite it so it's no longer a fraction. That's another technique sometimes for when we're getting into solving trig equations. So here's what, first time you see this, you're going to be like, why are you doing that? Again, you'll see it down the road. What I'm going to do is I'm going to multiply the top and the bottom. Remember, like when you are rationalizing complex numbers, or not rationalizing, but like rewriting complex numbers, we multiply by the complex conjugate. It's kind of the same idea. You've got 1 plus sine of x. I'm going to multiply by 1 minus sine of x on the top and on the bottom. Multiplying across on the top, I have 1 minus sine x. On the bottom, I'm going to get 1, you FOIL this, 1 minus sine of x for the outside. The inside is plus sine x. And last is minus sine of x times sine of x is sine squared x. Make the fraction bar continue there. These two terms simplify to 0. So 1 minus sine of x on the top. I've got 1 minus sine squared x on the bottom. Do you notice any identities? This right here has to start sticking out in your brain. That is a Pythagorean identity rearranged. Remember, we have sine squared x plus cosine squared x is equal to 1. Rearrange that. Pause the video, rearrange it on your own so it looks like the denominator. Okay, hopefully you got it. If you subtract sine squared x from both sides, you get 1 minus sine squared x on this side, on the right side, equals cosine squared x. So I'm going to substitute in place of 1 minus sine squared x, that cosine squared x. So this becomes 1 minus sine of x on the top over cosine squared x. Then I'm going to split my fraction. I'm going to put 1 over cosine squared x minus sine of x over cosine squared x. Okay, remember we have our reciprocal identities. 1 over cosine of x is secant of x, so 1 over cosine squared x is secant squared x. Done. That's no longer a fraction. Over here, I have sine of x over cosine of x, but not cosine of x, cosine squared x. I can pull apart that fraction and write that as sine of x over cosine of x times 1 over cosine of x. And if you think about it, if you were to multiply across, you get sine of x on the top over cosine squared x. It's perfectly legal. So we have secant squared x minus, what is sine over cosine? It's tangent of x. And 1 over cosine is secant of x. There you go. Boom. No more fraction. Now, could you continue on and do some different things? You probably could. You could factor out a secant of x. You could do multiple different things, but this is what I wanted to get to. Oftentimes, I'm going to tell you what I want you to get to, what I want you to make it look like instead of the initial, like when you're simplifying it, simplify it to this expression right here. I just want to see that you can get those steps. You'll have the answer, but it's the process that I'm going to be looking for on here. Okay, that's it.